This video is designed to give you an idea of what we mean or what we're talking about when we say PEMDAS. This is simply an acronym for the order of operations. It's a good way to remember it, but it has some confusing pieces which you should pay attention to. Obviously, P stands for parentheses, as I've written, and E stands for exponents, and you should do parentheses first, if there are any, and then exponents next until you've dealt with those. Once you've dealt with those, you should have multiplication, division, addition, and subtraction remaining. Any multiplication and division, crucially, should be done left to right as you would read them. And that means that if you were looking at, for example, something like 3 minus 5 plus 2, you would do this left to right, and you would get 3 minus 5 as negative 2 plus 2, and negative 2 plus 2 is 0. You would not do the addition first of 5 plus 2 and then subtract 7 from 3, but rather you would do this left to right as you would read them. This is true for both multiplication and division and for addition and subtraction. So I emphasize that by putting multiplication and division on the same level and addition and subtraction on the same level. And both of these are done left to right. So we've given one example with addition, and an example with multiplication and division might be if you did 12 divided by 4 times 3. When you did this left to right, and there are no parentheses, so there's nothing telling you to do it any other way, you would do 12 divided by 4 and get 3, and then you would still have 3 times 3, which would be 9. This is not 12 divided by 12, which would give you 1. On the next slide, we'll show an example of working an order of operations problem, and I'll talk you through that as well. So here are two examples. They're actually identical other than the fact that I've inserted parentheses into the second one, or the right-hand one. So let's do the first one, and let's talk a little bit about how you should document your work. In other words, each time you interpret something based on order of operation, or PEMDAS, you should show your interpretation by writing the next line clearly, allowing us to see how to make judgments or interpretations from that point on. So we look at this first problem on the left, and we look at that and we say there's no parentheses, and there is an exponent, and the first thing that exponent sees is the 3, which means only the 3 is being squared. So we should interpret this as 5 minus 2 times 9, because 3 squared is 9, minus 10. Now, to look at this further, there's no parentheses or exponents remaining, so there's only multiplication and division. Since there is no division in this problem, we do the multiplication problem, which means we do 2 times 9, which would give us 5 minus 18 minus 10. Now, what we have here is a left to right problem of addition and subtraction. You could rewrite it as an addition problem, but you can simply do this as a subtraction problem going left to right. 5 minus 18 is negative 13. There are 5 positives and 18 negatives, so the negatives win, and they win by a margin of 13. And then we have negative 13 minus 10. Now that is equivalent to negative 13 plus negative 10, which is simply saying we have negative 13 and then we go down 10 more, so that will give us negative 23. Now notice how I've shown each step. Every time I make a judgment or an interpretation of what's going on, I try to show the next line so that then I can make a good PEMDAS or order of operations judgment on that next line. If we look at the problem on the right, let me box in the left-hand problem. If we look at the problem on the right, the parentheses now take precedence, so we should do that first. what that tells us to do is 5 minus 2, which is 3. And then it will be 3 times 3 squared minus 10. Now, since we have exponents, we should square 3. And that means we're squaring this 3. I recognize that that can be fairly confusing. But we are only squaring that 3 because that's the first thing that the exponent 2 sees. So we should interpret this as 3 times 9 minus 10. Now, of course, we have some multiplication to do. So 3 times 9 is 27 minus 10. And 27 minus 10 then is 17. Note, of course, that we got two very different results from simply inserting parentheses. You can do this yourself by writing a string of numbers and operations between them, and then inserting parentheses at random and trying to play with that and come up with different answers. It's actually kind of fun to take maybe 4 different numbers with different signs, operations between them, and see how many different answers you can get or results you can get by inserting parentheses in all sorts of different places. Have fun with that and move on to some of the other worked examples to see how to deal with more complicated problems.